The view of the starry sky at night is simply breathtaking. Anyone looking at the thousands upon thousands of twinkling objects in the coming months could be forgiven for thinking another star had graced the cosmos. But that is not the case, because NASA has announced that it is the result of a raw natural spectacle that once again shows us the elemental forces of the universe. But what is it about? Why does T Coronae Borealis shine 1,000 times brighter than before? Will a celestial body drown its surroundings in a devastating explosion, or hasn't the breathtaking magic of space always been associated with chaos and destruction? After all, modern observatories in remote places, high-quality telescopes and an expert team of famous astronomers are all that we need. Not be amazed by the massive transformation of T Coronae Borealis. In the constellation Kronos, about 2,700 light-years from Earth, there is a brilliantly bright change in the TCB that we can see with the naked eye. Anyone with ordinary binoculars can admire the star for a little over a week before it disappears into the darkness of space for the next 80 years. Strictly speaking, the term star is not correct. We are actually looking at a stellar composite, a so-called symbiotic star, consisting of an extended red giant and a compact white dwarf. Brief classification: experts define red giants as aging solar mass stars whose cores have stopped burning hydrogen due to lack of accretion. White dwarfs, on the other hand, represent the hot cores of red giants, which are left behind when the outer shell is left behind in the final stages of the star's evolution. That the binary dance in TCB is anything but restrained is evident when we look at the distance between the two celestial bodies. It is estimated as half an astronomical unit, half the average distance between the Sun and the Earth, or about 75 million kilometers in number. The objects take 228 days to orbit each other, and as a result of the space constellation, material flows from a red giant to a white dwarf. This brings us to the reason that will bring us a scary phenomenon in the night sky in the coming weeks. What makes T Coronae Borealis shine? As soon as the red giant has fed the accretion disk of the white dwarf until it reaches a critical mass, fusion processes begin, which are reflected in explosive bursts of light. Such a process is known to astronomers as a nova. In TCB, so-called recurrent novae occur, which means nothing more than that the radio show repeats itself over time. This show is based on the self-ignition of a molten core during material transfer. The hydrogen disk and some of the helium accumulate into a much smaller white dwarf. Finally, there comes a moment when the material catches fire. However, this is not fire in the classic fire sense, but thermonuclear combustion, during which a thermonuclear reaction takes place in hydrogen. Indeed, eyewitness accounts of the nova date back to the year 127. Combined with observations over the following centuries, experts have determined that the binary star's nova outbursts last an average of 80.7 years. The last time this starlight was on was in February 1946. The next strike is expected to occur again in September 2024. Apart from these events, the apparent luminosity of the TCB is 10.8 mag, too faint for to be visible to our eyes on Earth. However, the last two novas in 1866 and 1946 were of magnitude 2.0, which meant that the binary star shone more than 1,000 times brighter than before, even surpassing Gemma, otherwise the brightest star in the constellation North Corona. As said, the next nova is already waiting in the wings, and given the 80-year pace, NASA is talking about a unique observational opportunity that no stargazer should miss. The main question arises: how at all can one recognize the supposed new star in the sky? The first step is to find the location of the constellation of the Northern Crown. It occurs as a small semicircle of stars between the constellations of Hercules and the Great Bear. Although you should usually choose a dark place to observe the night sky, even a slightly brighter sky can help with nova. Apparently better visibility can make it difficult to identify the desired object in the overflowing richness of the sky. But if you are in a bright place, you will only see the really bright objects that appear from behind the city globe. Rotating star charts or star charts are practical ways to track the current rising and setting times of the Northern Corona. When you enter the appropriate viewing location and time, the apps display current sky maps from which you can search for specific constellations. This letter makes TCB a little firefly. The bottom line is that there seems to be a universal rule in space: you can always get bigger. The sun often embodies the cosmic ultimate in our everyday perception, and this is also true of our home system. But the further we plunge into the vastness of space, the more our mighty host star dims into an insignificant pinhead. If we place a giant source of heat and life next to, for example, the star Betelgeuse, our central star must accept defeat in all astronomical aspects. Betelgeuse, in the constellation Orion, is 800 times the diameter of the Sun, about 1.12 billion kilometers. Theoretically, our big star would fit 500,000 times inside the so-called shoulder star of Orion. The differences in brightness are not that drastic. Betelgeuse appears 10,000 times brighter than the Sun. Thanks to this, the celestial body, which is located about 720 light-years from Earth, can easily be detected with the naked eye. If you're in the northern hemisphere looking at the starry sky during the winter months, the red supergiant is almost impossible to miss. Betelgeuse was already mentioned in 2,000-year-old documents as a yellow-orange bright spot in the sky. Like all other objects in the universe, Betelgeuse is not a rigid, unchanging celestial body. Determination of that radius by means of interferometry showed that it varies by about 15%. It is interesting to know that the radius of Betelgeuse was first determined using this measurement method. However, the stellar giant is also prone to frequent brightness fluctuations. For example, a visible change in brightness occurs every 270 days. This repeated interaction is due to the fact that the star has now entered a late stage of evolution. In short, red supergiants have the ability to re-expand and recontract. Pulsation is also always associated with changes in brightness. A few years ago, scientists were able to witness firsthand how drastic and confusing these changes can sometimes be. Is Betelgeuse going supernova? Already in October 2019, experts documented a strange process that finally led to a sharp decrease in brightness in February 2020. It was no longer even 40% of its average initial value. Besides, Betelgeuse has never been so dim since astronomical studies began. Some experts saw a decrease in light due to the overlapping of several light periods. Other scientists feared that the development was based on something much more dramatic: Betelgeuse could be on the verge of a supernova. Basically, the explosive death of a star is predicted by a celestial body that expands greatly and its brightness decreases significantly. However, since stars have not yet been observed immediately before a supernova, we do not know whether a similar dimming occurs several years or just a few hours before the explosive event. There is no doubt that one day Betelgeuse will indeed make an explosive exit. However, according to the current research situation, the red supergiant will say goodbye to the cosmic phase only in the distant future, because it reached the last phase only relatively recently. The final supernova is probably 1.5 million years away. Other experts have a much narrower time frame and expect the colossus to disappear from starlets within 100,000 years. When Betelgeuse returned to its former glory in April 2020, scientists discovered the reasons for the sharp decrease in brightness. Observations from the Hubble Space Telescope showed that the star had expelled the hot, dense material from the giant cloud. It then cooled, condensed into dust, and obscured the emitting starlight. Thanks to the cosmic dust veil, it was visible only from Earth, as if the celestial body had drastically lost its brightness. When an official explanation for the past development was found, the star did not take long to invent a new mystery. Starting in 2023, it shines much brighter than usual. Whether or not Betelgeuse explodes relatively quickly, one thing is certain: as soon as the red supergiant goes supernova, we will be impressively reminded of the elementary forces of the universe. Betelgeuse already shines 10,000 times brighter than the Sun, but during its explosive stellar death, scientists expect the brightness to increase 16,000 times. Some experts assume that the brightness of the star will then be comparable to the brightness of the crescent moon at night, while others to the brightness of the full moon. In any case, this event would be inevitable from a world perspective. The order button is also from your earthly perspective. Join our community and never miss an exciting video.